Hey everyone, thanks for joining us today. Nick and I are going to talk about some of the things we've learned in the field helping our customers, specifically related to running Istio in production. Next slide. Yeah, so my name is Vennam. I've been working on Istio for a long time now, pretty much like since the beginning, before Istio was 1.0. I spent a couple of years serving on the Istio steering committee. So now I kind of mostly focus entirely on working with solo.io's customers and just the Istio community itself. And with me, I have Nick Nellis, who's also a field engineer here at Solo.
Yep, thanks. I also have been working on Istio for a number of years, implementing it, also contributing to the Istio codebase. Now I spend a lot of my time helping our customers implement and architect and adopt Istio and service mesh best practices, production support. So I spend a lot of time helping our customers walk through the life cycle of using Istio and helping them with the gotchas, and then also keeping their environments healthy.
One of the biggest challenges with Istio that our customers face is around the lifecycle management of it. But really, the zero downtime upgrades is where a lot of our users get stuck on. How to go from one version to another when the versions are coming so fast, whether it's a patch update or a minor update. How quickly do you have to keep up, and how much time you want to invest in doing that? And when you're talking about zero downtime updates, Istio is just not one single monolith, right? There's the control plane component, there's a sidecar next to each one of your applications, and then there's the one or many gateways. So you're talking about several different components here, and you can't just update all of them at once. You kind of have to go portion by portion and test things out. So this has been a major pain point for our customers, and depending on the size of your environment, the amount of time you're willing to invest in your upgrade, and how often you're trying to do the update, and what your tolerance is for a potential downtime, we kind of have to build a custom solution for our clients. And we've been working with the community to kind of improve this approach over time. So we've written blogs on Istio.io as well as on solo.io for the various versions. These are just 3 blogs that we wrote over the last, I think all 3 blogs were written last year. And they go into the various ways you can go about updating depending on what your requirements are. The one that's all the way on the right, upgrading Istio to downtime, Nick actually wrote that at the end of last year for a customer that required absolutely, that had no tolerance for a potential downtime. So there was duplication of, we're doing like a blue-green approach where you deploy the old version of Istio, the new version of Istio, and you're kind of deploying multiple components. And that blog post we'll kind of go talk about in more detail. Thankfully, the upstream Istio project itself has come huge strides in terms of improvement on how to do update from one to another. Before, the only update was kind of directly in place, where you just update all the components, and then just kind of hope that everything works. But then gradually there were canary style updates where you can just do the control plane separately, but then you update your data plane in place, or you update your gateways in place. So there was basically a gradual transition when things improved. And right now, I feel like the upstream community is in a pretty good spot. And this is the current recommended approach from Istio.io. So let's say you're going from Istio 1.11 to Istio 1.12. Let's look at the box on the bottom of the screen, first thing you would do is you would deploy a second Istio version, and this would be your new Canary version. And Istio has the ability for you to use what it calls revision to mark the two as separate Istio-D installations. So you have your old control plane and the new control plane. So it's a new deployment that comes with its own Istio-D service, and it also comes with its own versioned injector as well. And then to update your data planes, which should be your next step, is instead of using the normal namespace label where you just say Istio injection enabled equals to true, you set that label istio.io/rev to the revision name, and that basically tells Istio which injector to use. So if you're starting from a clean slate, then all of this will be pretty consumable for you, meaning that you can always start off your fresh Istio installation on a revision called 1-11-5. You label all your namespaces to use that revision. And then when a new revision comes, you just update that label and then restart the workloads that are in that namespace. You do a rolling deploy of the workloads in that namespace. And then the new injector comes in and updates the sidecars to the new one. So so this diagram is showing a transient state where some of your namespaces are updated to the new one, and then the other namespace is not. And then once you've gotten your sidecars to update to the latest one, then you will deploy a Canary version of the ingress gateway. And these ingress gateways are using the new injection method of running them. So to talk a little bit about that, injected gateways are basically they work like the sidecar does, meaning when you first deploy a gateway, it's just a stub. And the injector, the Istio sidecar injector, will go fill in the correct proxy image and all the configuration. So it works very much like a sidecar where it's just a templated gateway. So this allows you to deploy a second gateway that runs next to your original gateway, but this time the second gateway was injected by the 112 sidecar injector. So now you have two ingress gateways deployed. Both of them will be exposed using their own Kubernetes service. So they'll have each have their own endpoint. Gives you a chance to test out the Canary version of the gateway. And then if all is well with the Canary version, then you can just do a straight in-place update of your original gateway, or just switch your external load balancer to the endpoint of the Canary ingress gateway.
I think a lot of customers that try out Istio aren't privy to the revision tags up front. All of the Istio examples don't really mention them until you get to a day 2 type operations. And so we see a lot of our customers today not using revisions in production. And when they're looking for safer upgrades, one of the first suggestions that we do make is that they actually migrate to a revision-based deployment. Yep. And future upgrades after that go a lot smoother and a lot safer.
Right. So in a nice greenfield environment where you're starting from scratch and you just have a couple of a few namespaces and a few apps, then this approach might work for you. But really, like, Istio is not the center of our customers' world, right? Like it's meant to be yet another tool to solve a particular challenge in the Kubernetes stack. So they don't have like that much amount of time to orchestrate this revision Istio with like a second revision and then switching from one namespace to another. Like this is a very simple environment, and sometimes the Istio documentation makes it. You get the feeling that they think that your whole world revolves around Istio. So like this orchestration is not something that our customers typically want to deal with, at least most of them. Because most of our customer environments don't look like that, but instead they look something like this, where there's lots of different namespaces. Each namespace is owned by a different team. There's applications talking to one another. So you can't you can't just set aside a time that says, here's a new revision. I want every single namespace to, slowly migrate over and test to see if things are working. And if they are, then we'll do more namespaces. That's way too much time and orchestration for a large percent of our customers. So they need more of like a tailored approach. So that's where you like kind of really need to come up with a plan on how you want to handle your Istio updates before you go down the path of installing it. If it's very important for you to do that approach, then yes, by all means, adopt revisions, do everything correctly. But for some of our customers, that's too much overhead, and they would rather just spin up a new cluster with a new Istio version and move things over. Or they have like failover backup clusters or active clusters where they can partition one of the clusters off for construction and then update it. So we'll talk a little bit about that. So in order for you to do things like that, where you have multiple clusters and you can just kind of, pick one and say like, okay, this is under maintenance mode and update in place, and then pick another cluster. A management plane would really, help in that orchestration. The Glue Mesh, our Glue Mesh product comes with a management plane, meaning that this management plane is typically runs in its own separate cluster. And then each one of your workload clusters, they have a management plane agent, the Glue Mesh agent, that reaches out to this management plane to get its config. That allows you to have a single place, the management plane, where you apply all of your service mesh config, and that management plane will kind of distribute that config to each one of your worker clusters. That also simplifies east-west cross-cluster traffic. So one Istio cluster knows about the endpoints of your applications in a separate Istio clusters, and it can fail over across clusters just as easily as it's sending traffic to a local cluster. So it really like helps you kind of group all of your clusters together and build one, essentially one larger cluster, which we call, a virtual mesh, which is a grouping of multiple meshes together, and you can do traffic routing between them.
That's a really important concept. Like that's something that doesn't exist in Istio today, is a global representation of your environment. Istio is really isolated kind of to your local clusters. And so you need a way to tie those all together so that they know about the wider environment that they run in.
Exactly. So you can use, you might be thinking, oh, I could just use like some sort of CI/CD solution to like stamp out multiple clusters for like an active setup. But when you do that, you're not enabling cross-cluster routing. So if in this example, if the recommendation app on your left were to go down for whatever reason, whether it's crashed out of memory, the node went down or whatever, you want the web API service to just automatically fail over to the recommendation service running in a different cluster. And you want to be able to do that without intervention, right? Without, definitely not a code change, but you don't want any sort of explicit policy to enable you to do that. So a management plane can help you group applications together across your various clusters and kind of treat them as one. So you'd have one endpoint for your recommendation service that's backed by applications across multiple clusters. So what that now then allows you to do is very easily block a cluster from your ingress traffic, your main north-south traffic, and then let this failover, work its magic so that all the endpoints are propagated to your other clusters, and all the traffic continues to work. And from an external client perspective, they don't even know that anything happens. The beauty of the management plane is that management plane can handle multiple Istio versions. So cluster West 1 can be Istio 110, cluster West East 2 could be Istio 111, and the management plane will abstract away those differences and give you a simpler API that is multi-cluster aware and multi-Istio version aware.
Alternatively, you could also bring up a new cluster with those applications. And with this management plane, I can automatically detect those applications and those gateways and then add them to the pool of resources that you're already routing to. And so you can also expand as well as, take things down for construction.
Yep. One thing that we're doing with our Glue Mesh management plane is trying to take over this Istio lifecycle management. So from the management plane, you can apply a custom resource, like let's say in this example, we're applying this Istio installation custom resource, which tells the management plane what Istio installation you want to install and on what clusters, what profile, and any overrides. So it's like an abstraction on top of the Istio operator API that is multi-cluster aware. And then the management plane will take care of figuring out what it wants to name the revision and how it wants to do the update and the installation in each one of those clusters. The next portion I want to talk about is observability. So Istio does somewhat comes with like out of the box observability tools. They don't come with like the default profile, but if you install the demo profile or just go to, I think there's an add-ons documentation page, it tells you how to deploy a demo version of, Grafana, Prometheus and Kiali, etc. The reason why it's just like a demo instance is because for a production instance of these observability tools, you would need to have a true like persistence layer where it can save all of this information, all these metrics, traces, etc., so that you have a historical record and you can go back and observe patterns. But and most of our customers do have things like that, or at least like Enterprise Prometheus, or they have things like Datadog. The point I'm trying to make is that the add-ons that come out of the box with Istio are good for you to get started, but you should immediately like move on off of them and integrate with your existing observability systems. That allows you to maintain things like much longer historical records, not have to do like an Istio specific dashboards. Instead, you're integrating it with your existing infrastructure and kind of just make it more pervasive and part of your normal Kubernetes application deployment lifecycle. Another thing that you should not be scared to do is create your own custom Grafana dashboards. This one is a great example, and I'm going to let like Nick talk about this because he actually helped one of our large customers identify performance issues with their environment by creating these dashboards.
Yeah, so we had a customer that very experienced with Istio in a large environment doing some artificial intelligence, but they were having some performance degradation in a number of different areas of Istio. And when they looked at those dashboards that Istio gave them out of the box, they were quite overwhelming in terms of what do I need to look at and what do I care about. And so we hooked into their existing metrics, which they were using Grafana. We created some custom dashboards for them that highlighted the things that they needed to care about in terms of debugging and solving some of their Istio-related problems. And this was at a pretty large scale, so we were looking at thousands of pods and thousands of services and some pretty big environments. And then they also had Knative on top of it. And so this dashboard just really helped them dive deep into the things that they cared about and were trying to tune, and specifically memory usage with each sidecar, and then the response times of the Istio control plane. And so we put a lot of metrics around those areas to see if we could, bring down that memory usage and then also bring down the translation times. And so definitely don't be afraid to isolate down to the things that you care about when you're looking at Istio.
Mm-hmm. As you grow to multiple clusters, one of the benefits of a management plane is that it can act as a metrics aggregator. In the Glue Mesh scenario, on each one of the workload clusters, we run this enterprise agent component that acts as a metric sink. which goes and scrapes all the metrics from each one of your application pods and then sends that to the management plane. It decorates those metrics with information like the cluster metadata, for example, and then it sends it to the management plane. And the management plane could be a place, the management cluster can be a place where you deploy your Prometheus server, your production Prometheus server that aggregates Istio metrics across all of your workload applications. And then you can use your own observability tools that sit on top of that those metrics, or use the Glue Mesh dashboard that kind of comes with the product. So this is an example of a multi-cluster service graph where you can observe things like cross-cluster traffic, failover, whether your pods are using MTLS, et cetera. Nick, I'm going to hand it over to you to talk about debugging.
Great. Yep. So as you mature through your lifecycle of Istio, you eventually need to start looking at some of the internals. You need to get familiar with the tooling, the architectures to help you be successful with Istio. It isn't something you can just drop in and hope it never has problems, because there ultimately will be problems, but with the proper tooling and the proper observability, you can actually isolate down and hopefully remedy them relatively quickly if you empower yourself. But debugging Istio is hard. And the reason for that is that you have a number of different roles and responsibilities that all tie into Istio. You have the developer who uses those sidecars to abstract away its logic and then handle security, routing, outlier detection, circuit breaking, stuff like that. So a lot of the functionality that developers are kind of used to has now moved out into the Istio landscape. You have operations, managing Istio, the lifecycle of it, upgrading, monitoring, and just making sure that the environment is healthy for those workloads that the developers are putting onto the platform. And finally, you also will have a lot of reasons that Istio is used today is for security. And so most often our larger customers have security teams involved within their Istio deployments. And that's making sure there's uniform policy enforcement, such as like an MTLS policy that all communication is encrypted and authenticated. Certificate management is actually a pretty big thing within Istio that we are now seeing our customers really utilizing to hand out those, enable MTLS. And then application access. So you're able to say within an Istio mesh, which applications can talk to other applications and which ones can't. And so that's something that security often wants to audit to make sure that they have scoped down those resources to the least privilege that is needed.
Yeah. Well, one of the things that's interesting is that when Istio was new and bleeding edge, we didn't quite have these like personas laid out quite as clearly. But now as Istio becomes more and more mainstream, we're noticing that these developer operations and security personas be more clearly delineated, where each one of them has a specific use case that they want out of Istio.
Yeah, and so where the issue happens with Istio, it can affect one or many of these personas, and it requires many people potentially to get involved. But thankfully, there's a tool for everyone, and that is provided by the Istio community, known as Istioctl. It is our go-to tool for debugging most of our Istio problems within our customers' environments. And the reason being is that it tries to visualize or make known more internals of what Istio is doing, from the control plane or even debugging the sidecars themselves. And that goes from secrets to the Envoy proxy configuration to the health of your Istio control plane. And so all those personas should get really comfortable with using Istioctl. And we're going to talk about some of the different ways that we use it for some different use cases that are pretty common in our customer environments. So the first one this one is definitely more of a developer related role, even though it's pretty deep and internal to Istio. Kind of a operations side as well. Those sidecars that are running on each application are Envoy proxies. And somebody is going to eventually have to go and look at that Envoy configuration to make sure, if it's correct or functioning correctly. And so depending on who wants to take up that responsibility, Istioctl kind of enables you to get a pretty good view of those decisions that are being made by Istio to program the Envoy proxy, whether it's setting up the listeners for the inbound ports and protocols, or where traffic is routed, or how it's manipulated, such as request header, if you're adding request headers or Envoy filters, and then finally the Envoy clusters, which helps determine where the traffic is going to be routed and how it's going to be routed. And so you can see multiple roles coming in here. For example, the security role may come and take a look to make sure that MTLS is being enforced. They just want to check. They may need to check that the configuration meets the security requirements of their organization. And we've had certain organizations actually do an audit of their configuration to make sure that it is to what their standards expect.
This is a good way for you, like Nick is saying, this is a good way for you to audit, to verify, to debug the applied configuration. At the end of the day, all Istio is doing is it's converting your Istio APIs to thousands of lines of Envoy config. So using the Istioctl tools, you can actually go look at a subset of that Envoy config to make sure that Istio has done what you expected to do. And if there's not, then you know where to look exactly.
And even if you're an expert in Envoy, the Istioctl tool still works really well for you because of that querying ability to isolate down to the ports you care about or the traffic that you're targeting.
Yeah.
So this one is a little bit on the deeper side of Istio that we've actually been using with customers quite a bit lately. And that's being able to change the log levels in real time of your Istio proxies or your Envoy proxies. And so sometimes, especially in multi-cluster environments with MTLS turned on, we notice that the default logging within the Istio proxy does not log a lot of the internals. And the one I'll talk about is TLS, the TLS layer. And so this is a really important command to know when you're debugging Istio, is that if you need to really see what Envoy is doing, you can actually enable the debug logs in real time. It's pretty verbose, and so they offer a number of different types of logging configurations. So at the bottom, you can see, I believe there's like 27 or 28 of them. You can enable them individually at the level you want them to log at. So typically we are looking at connection level stuff. So we enable the connection debug logs or trace logs. And this has really helped us debug our environment. And I'll show you why. So this is an example of a simple multi-cluster request of flow from one application to another. We have the product page application in cluster 1, and then the reviews application running in cluster 2. And for those to actually communicate, we do a number of hops. We first exit the first sidecar. An MTLS connection is made all the way directly to the pod in the second cluster. And so what that means is that it is secure and encrypted through the cloud load balancer and the Istio east-west gateway directly to the final destination. And so if you were to take a look at that cloud load balancer or the logs from the east-west gateway, you're only going to see your typical TCP statistics. You're really not going to see, actually in the default logging level of Istio, you won't even see the traffic flowing through the east-west gateway. And so what we can do is we can enable the reviews sidecar to log that debug level connection. And we can actually see in below here that the certificate verification was failing at the TLS level. And so without this enabling this debug thing, you actually wouldn't see any problems. You would just see these two pods not being able to communicate. And so this is actually a very common thing that we do with our customers. But without knowing about this command, it's very, very hard to debug.
Yep.
And then finally, we're going to talk about how virtual machines are becoming a growing concern amongst our customers, and what kind of architectures and what kind of patterns we've been seeing more of for our customers who want to take potentially legacy applications or applications that are not fit for cloud environments yet, and joining them to your service mesh. So we're going to start with a little bit of a simple architecture here of how would you join a virtual machine that doesn't exist in a Kubernetes cluster or a service mesh. How would you join that to Istio? And the sidecar communicates over a protocol called XDS. And so what we do is we install, you can install an Envoy proxy or an Istio proxy in that virtual machine, and then have it communicate back with an Istio control plane via this XDS protocol. And we do that through typically an east-west gateway. So you get secure encrypted communication between the virtual machine proxy all the way to Istio. And so that's a typical architecture of joining a virtual machine to an Istio mesh. But we've actually worked with some other customers to come up with some alternatives, because a lot of times this isn't feasible in everyone's environment. It may be too much overhead to install an Istio proxy on every virtual machine, or they may have incompatible operating systems. And so we'll walk through some architecture patterns on some alternative ways that we've been helping our customers join virtual machines to the service mesh. The request flow is actually very similar as well. And so if an application in the virtual machine wants to communicate with an application in the service mesh, it actually just passes through the proxy, the Envoy proxy, and then is using MTLS. We pass it through the east-west gateway onto its final destination. And so your virtual machine is communicating securely and with an identity when it's calling an application inside the mesh. And so you're getting a lot of that same service mesh features, even though you're not in the same Kubernetes cluster. Today in Istio, this is probably the number one reason why customers don't shy away from adding their virtual machines to the service mesh. And that's because the current setup is a little bit complicated and hard to automate. And so I laid out here the 7 steps that are required to set up a virtual machine. And so what we've been spending a lot of time here on at Solo is how do we make this easier and more consumable for a wider audience? And that's by looking at the requirements of our customers and how we can design solutions that fit their needs. This solution kind of seems like a one size fits all, but a tailored approach definitely has allowed some of our customers to make some leaps and bounds in this area. And so recently, I've actually published a couple of blogs related to how can we make this easier. And the way I did that is by looking at the actual requirements of our customers, and then scoping the requirement, scoping down the what they need to meet those requirements. And so I was able to reduce complexity by offering still a lot of the features that they were looking for. Now, they may not get all of the service mesh features that you would expect from being inside of a Kubernetes cluster, but it still allows you to communicate securely and authenticated within service meshes. And so, if you're interested to learn more, you can check out my first blog post on Istio.io about the different types of use cases that make this easier. And then I have an implementation on the Solo blog site that explains in detail how you can set up and run this yourself. One final thing I did want to mention too is that designing these architectures based on our customers' environments and how they are in real life has allowed us to make some strides in customers who wouldn't typically adopt virtual machines joining service meshes, but we've now been able to connect data centers and clouds. And so we've been designing architectures that make it easier for you to like migrate your virtual machines to the cloud in an iterative pattern. And we'll walk through that next.
Yeah, you'll notice like that's kind of like a common pattern with our relationship with our customers that we partner with, is that they've noticed that upstream Istio solution to things like zero downtime upgrades or scaling or VM expansions tends to be a more complex solution because it's trying to cater to a wider audience, more wider set of use cases. Whereas what we're able to do is kind of get to the root requirement and build a solution that is much more simpler for the customer and enables them to actually do things like bringing VMs into the mesh. Like this example was really good because in this case, the customer only needed one-way communication. So we're able to say, oh, okay, well, then we don't have to do, this, B, C, D, and E. You just need A. So let me just give you a simpler way to do this solution.
The other thing that our customers are going to ask for is running Istio or connecting Istio in different kinds of environments. So today, the default Istio installation only works for a few select environments. But we've been finding that our customers are asking for it in a lot of different environments that they run in today. And so the biggest ones are Docker and potentially Windows. And so they're looking for solutions that Istio just doesn't offer today. And so we've been actually working to make that a lot easier as well. And a side effect of that is we've actually been able to connect local machines. So we've enabled developers to connect their local machines with service meshes as well, so that their software development lifecycle can include testing with live environments in real time. And so some of these solutions have actually enabled companies to improve the speed of delivery because they can test how their application will behave in a service mesh environment. Another architecture pattern that actually we saw is that instead of installing Istio proxies on all of your virtual machines, it made more sense to install a forwarding proxy that gave those virtual machines access to service meshes. And so we helped a customer design a virtual machine that just had an Istio proxy on it that we manually configured to allow virtual machines to securely communicate with applications in the service mesh. And this was a nice temporary solution for them to allow them to migrate those virtual machines into their Kubernetes clusters over time. And so they're now in the process of deprecating those virtual machines and moving them one at a time. This solution also is enhanced if you put it behind something like Glue Mesh. And so with the power of Glue Mesh in that global view with the management plane, you now can be able to actually route to any east-west gateway within your mesh, and Glue Mesh will help that request figure out where it needs to land. And so this is offering a high availability now to your virtual machine requests. In my example here, you can actually call any east-west gateway within Glue Mesh, and the request will be intelligently routed to the nearest application. And so by adding a management plane on top of all of your Istio clusters, you can actually enhance the uptime of your virtual machines communicating with applications in the mesh. And then finally, one thing that we're doing here at Solo is we're trying to make that installation a little less painful. And so we just launched a new Meshctl command called Meshctl VM that helps you set up the required components within a virtual machine and then validate that they're operating correctly. And so at the release of this recording, you can go and try out the latest beta version that includes this solution and help you try out adopting VMs and bringing them into your service meshes. And that concludes our operations talk today. If you're interested in more about day 2 operations, we do offer a number of courses. And we actually are just launching a new Istio Expert Certification course. And so please check that out on solo.io.